Hey, Susan.
Let's talk about probability. Simple probability.
All right, sounds good. I will just say that in this section, probability is something that everybody kind of has a general idea about, what probability is. But we want to talk about some specific kind of words and formalize it a little bit.
Yes. And two of the main terms we're going to look at would be the sample space and the event.
Yes.
And the sample space is really all the possible outcomes you could have for something happening. It's everything that could possibly happen. Mm-hmm. That's the sample space.
Yeah.
And the event is it's the successes. So it's really kind of what you were counting up. An example, if you're rolling a die.
Right.
And and I know we're going to cover this in a minute, but the sample space would be 1, 2, 3, 4, 5, or 6.
Right.
You're going to get one of those.
Yeah.
But if you're counting up the 2s, then every time you get a 2, that's the event.
Right. Right. And that's a subset of the sample space.
Yes.
Because the sample space is all possible outcomes.
Yeah.
Right. And so when we calculate probability, we're really calculating, the cardinality of the set E.
Which means how many elements are in that set. The count them up.
Yeah. And then divided by the cardinality or the size of the sample space.
Yeah. How many could have happened.
So when we define probability this way, our theoretical probability, because the event is a subset of the sample space, then our probabilities have to be between 0 and 1, right?
That's right, because it's going to be what I think we used to term a proper fraction.
Exactly.
Right?
It's a proper fraction. And so could I have a probability that is like 200%?
No.
Right. That would not be something that would be considered a probability. Okay.
Correct.
Probability and odds are different things.
They
and
are.
So
They
that's something to keep in mind.
And we normally write our probabilities as decimals. So we'll normally write probabilities like 0.024.
Right. And that would be an appropriate way to write a probability.
Yes.
Yeah. I could also write, 11 over 20. Right?
Yes.
That would be okay. Or 12%. Right.
Yes.
Those are all kind of acceptable probabilities. They're all between 0 and 1 or between 0 and 100%.
Yes. 0 and 1 if you're using the decimal format, and 0 and 100 if you're using the percent format.
So let's think about this. We talked about rolling a fair 6-sided die. And what did you say the sample space is there?
The sample space, S, would have the elements that are in S would be 1, 2, 3, 4, 5, and 6.
Right. And so the size of S,
or the cardinality of S, is 6 because there's 6 elements in there.
Right. So if I want to find the probability, okay, where I am rolling an odd number greater than 1.
Oh, snap.
Okay. Then I would need to know, how many successes do I have and
how many possible successes do I have out of how many options I would have? Well, I know the denominator. I'm rolling that die. I have six chances.
Yeah.
But the numbers, the odd numbers that are greater than 1, that would be
3 and 5.
3 and 5. So there's 2 of them.
Right. So that would be 2 over 6. I could write that as 1/3. Or I could write that as 0.3333.
Or you could write it as 33.3%. It's just according to how we're asking you to report it. Those are 3 different ways of reporting the same thing.
Yeah.
Could we, since we wrote the cardinality of S, and we wrote S out, could we write E so we can see it and write the cardinality of E?
Yeah.
E was 3 and 5, right? Those are the only 2 things that would meet the requirement that we were looking at, which was odd and greater than 1. Yeah, so the cardinality of E was 2. Good.
Yeah.
Okay, rolling values that are greater than 6. Well, let's look at our E. Let's go over there and write our E out.
E would be the empty set.
Yeah, there are no values greater than 6. So the cardinality of E is 0.
Right. And so that would be 0 over 6 or just 0.
Yep.
Right. Okay, rolling an even number.
2, 4, and 6 would be the 3 even numbers. And so that has a cardinality of 3.
Mm-hmm.
So it would be 3 over 6.
Right. Or I could say 1/2, or I could say 0.5, or I could say 50%.
That's it.
Right.
Okay.
Okay, one last thing that we'll talk about here in this pre-class video is the idea of a complement.
Oh, yeah.
Yeah.
I like your hair, Christina.
That's not what I mean by compliment, Susan. But thank you. It's rather nice today. So the complement is the opposite of an event. So technically, it is the subset of outcomes in the sample space that are not in the event.
Oh, this is more like when you say this complements that, and it's kind of like it fills in all the gaps of the other.
Exactly.
I see what we're doing.
Yeah,
Okay.
Yeah. So the rules for that, because an event either has to happen or not happen,
That's right.
right? When I add those together, I have to get 1 or 100%. Okay, so our probability rules for complements
Let's
are
talk
that.
about, we're going to talk about how to write a complement
Oh,
first.
sure. We usually use the bar over the letter that is representing the event.
So the probability of A would be the probability that A occurs.
Yes.
And so the probability of A bar
Would be the probability that A does not occur.
not event.
Yeah.
I mean, not occur.
Yeah.
Event. Not occur. Yes.
Yeah.
And, or we can use A prime, but normally we use A bar.
Yeah, so for example, if I am using the dice,
Which really reads not A bar. It reads not A.
Right,
Probability
yeah.
of not A.
Yeah. The probability of rolling an odd plus the probability of getting not odd, right?
Yeah.
Right, would have to equal 1.
Yeah, because
Yeah.
the not odds would be the evens.
Mm-hmm.
Yeah.
Exactly. Yeah.
Okay.
Yep. Which, that makes sense, right? Because I would have 3 out of
Odds, which are
6.
1, 3, and 5, and then we've got 2, 4, and 6
Mm-hmm. And that
for
equals
the not odd. Yep.
1.
Good
Okay.
example.
Yeah. So if I said that the probability of an event equals 30%, what would you say the probability of the complement is?
The probability of the event not occurring would be 70%.
Exactly. Good. All right, and we'll talk more about this in lecture.
Okie doke.